Okay, this is the second part of my videos. The first one contained a few of the problems. I'm going to go through and finish working out the other problems, or most of them. So let's start off. Okay, we're going to work number 2. It says to find the slope of the line passing through the given points. So you have 9, 1, and -9, -3. So remember, slope is rise over run. So at the part we'll find the change in the y, which will be -3 minus 1. And then change in the x's, -9 minus 9. So -3 minus 1 is -4. -9 minus 9 will be -18. Okay, we can simplify that. Negative over a negative would just be a positive. And then we have 4 and 18. Those are both even numbers. Divide by 2. You'll get 2 over 9. So that will be the slope for number 2. And if you need to, you can label these points. Remember, every coordinate is going to have an x and a y. So we have x1, y1, and x2, y2. So that's where I said -3 minus 1, and then -9 minus 9 to get 2 over 9. Okay, number 3 was completed for you on the other video. So we're going to look at number 4. Number 4 says to write an equation of a line perpendicular to the given line that contains point P. Okay, so this line is y equals -3x minus 15. And it needs to go through point P, which is 4, 3. Oh, I wrote the wrong problem. That was number 6. Okay, back it up. Okay, number 4. The line is y equals 4/7 x plus 7 and 2/7. And the point C is 7, 1. So we're trying to write an equation of a line parallel to line AB that contains point C. If the lines are parallel, that means that the slopes are the same. So we need to find the slope in this line. Okay, it's already in slope-intercept form, so we know that the slope is here in front of the x. So the slope for this line is 4 over 7. Okay, so the slope of the parallel line is also going to be 4 over 7. Okay, and we want to go through this point. So the slope will be 4 over 7 also. Okay, and we can use the point slope form, which is y is equal to slope times x minus h plus k. Okay, and using this point slope form, we're just going to plug in our slope, our h, and the k. Remember, the h and the k are your point. Okay, so we would say y, we know the slope is going to be 4 over 7 times x minus h would be that 7, plus the k would be 1. And you can leave it like that, or you can put it into slope-intercept form by distributing the 4/7. So y is equal to 4 over 7x, and then 4 over 7 times -7. You imagine it's -7 over 1. So I'm going to put plus 4 over 7 times -7 over 1 plus 1. And then go over here. That means y is equal to 4/7 x. And then 4 times -7 will be -28. And then 7 times 1 would be 7 plus 1. And I'm just showing you all the steps to see if you have any questions. Negative 28 over 7 would be negative 4 plus 1. And then negative 4 plus 1 would be negative 3. Okay, number 5 is on the other video, so you're welcome to watch that. And I'm going to do number 6. Number 6 here. Okay, number 6 says write an equation of the line perpendicular to the given line that contains P. So here's your given line. And we want to contain point P, which is 4, 3. Okay, once again, we're going to use the point slope form. Well, before we do that, let's talk about, we're writing an equation of a line that's perpendicular to the given line. Okay, so we want to find the slope of this line, and it's already in slope-intercept form, so the slope is negative 3. Okay, and the slopes of perpendicular lines are negative reciprocals of each other. Okay, so this slope is equal to negative 3 over 1. So the slope of the perpendicular line is going to be reciprocal, which would be 1 over 3, and since this one's negative, this would be positive. So it's a negative 3, so I put negative 3 over 1. Slope of the perpendicular line, reciprocal, 1 over 3. This one's negative, so this will be positive. Okay, so the point is 4, 3, and the slope is going to be 1 over 3. So if I have y is equal to m times x minus h plus k, I can plug all of that in. My slope is 1/3 times x minus h is 4 plus k is 3. Distribute all of that for slope-intercept form, 1/3 x, or you could just leave it. 1/3 times negative 4 over 3 plus 3. So you have y is equal to 1/3 x, negative 4 over 3 plus 3. So I have negative 4 over 3. I'm going to get a common denominator of 3. I'm adding 3 over 1. So common denominator would be 3. 1 goes into 3 times. 3 times 3 is 9. So negative 4 plus 9 will be 5 over 3, positive 5 over 3. Or you could say 1 2/3. So y is equal to 1/3 x plus 1 2/3. Okay, number 7 is on the other video. Number 8, it says rewrite each equation in slope-intercept form. Then determine whether the lines are parallel, perpendicular, or neither. Okay, so the first line is y minus 1 is equal to negative x minus 6. Slope-intercept form, y equals mx plus b. I need to get y by itself, add 1 to both sides. Then I have negative x, negative 6 plus 1 would be negative 5. So the slope for this line, we'll call it y1. The slope is here in front of the x. That would be a negative 1. The other line is y minus 3 is equal to negative 5, 6 times x minus 5. So we'll get in the slope-intercept form. Okay, I'm going to keep this as y minus 3. I'm going to go ahead and distribute the negative 5, 6, and x. I'm going to go ahead and distribute the negative 5, 6 with x and negative 5. So this is negative 5, 6, x, and negative 5 over 6 times negative 5 over 1. Negative 5, 6 times negative 5 over 1. We already know what the slope is, but I'm going to go ahead and put it in slope-intercept form because that's what the directions tell me to do. So negative 5 times negative 5 gets a positive 25 over 6. So I can go ahead, let's see, and I'm going to go ahead and add 3 to both sides. So y is equal to negative 5, 6x plus 25 over 6. And we have a common denominator. 1 goes into 6. 6 times 3 is 18. And 25 plus 18 is 43 over 6, which that would be 643 7 times, and with 1 6 left over. Okay, but we know our slope of the line is negative 5 over 6, and this slope is negative 1. They are not the same. They're not negative reciprocal to each other. These lines are not perpendicular. They're not parallel. So that would be neither. Okay, 9 through 12. Use the diagram at the right. Complete the congruence statements. And ABC is congruent to XYZ. Remember, A corresponds to X because they're the first letters in the congruent statement. A is congruent to X. B is congruent to Y. And C is congruent to Z. Angle C and angle Z. And all of their corresponding sides. Okay, so AB, segment AB, you can look at the picture, but it's a lot easier to look at the congruent statement. AB is congruent to XY, segment XY. Okay, ZY, segment ZY is congruent to segment CB. Okay, angle Z corresponds to the last letter, angle C. And then angle BAC corresponds to angle YXC. And of course, you can use your picture, but a congruent statement is sometimes easier to use. You look at it that way. 15 through 17. Can you prove these triangles are congruent? If so, provide the postulate or theorem that proves this. If there is not enough information to prove the triangle is congruent, write not enough information. Explain your answer. Also provide the congruent statement for the congruent triangles, which means A, B, C, and X, Y, Z. So 15, we have this side marked congruent to this side, and this side congruent to this side. We also have a pair of vertical angles. So these triangles can be proven congruent by side, angle, side. Where the two sides meet, the angles in between those. Side, angle, side. Side, angle, side. Okay, and the congruent statement would be triangle PFT is congruent to triangle T corresponds to G, F corresponds to S, and T corresponds to T in the other triangle. Okay, number 16, we have these two sides marked. There's one S. We have these two angles marked congruent. There's another angle, and they share this side in between them. Is it side, angle, side, or would it be side, side, angle? Notice where the two marked sides meet, here and here, that's where the angle is formed. So yes, these two triangles are congruent by side, angle, side. You have to make sure the other triangle matches, and it does. So side, angle, side is the answer. And then your congruent statement, triangle PFE is congruent to triangle. And it doesn't matter what you put first, they just have to correspond to each other. Angle P corresponds to angle R, so that goes first. F corresponds to F. E corresponds to E for those. And number 17, we have KM is marked congruent, LO is marked congruent, MO is congruent to KL, and they share the side in the middle. So all three sides of this triangle are congruent to all three sides of this triangle. So the answer is side, side, side. The congruent statement, triangle KMO is congruent to triangle. K corresponds with O, M corresponds with L, and O corresponds with K. Okay, and then back to 13 is on the other video. We have the line y equals negative 3/4 x minus 1, and we want to graph each line mentioned below and the line parallel through 3, 2. So we have this first line. It's in slope-intercept form. -1 is the y-intercept. So we go down, find -1, plot that point. The slope is -3/4. That means you go down 3, 1, 2, 3 to the right, 1, 2, 3, 4 for your slope. We don't have enough room to do that again, so we will go backwards. So from the y-intercept, go to the left 4, 1, 2, 3, 4, up 3, 1, 2, 3. Oops, I need to mark that. Okay, so the slope is -3, 1, 2, 3 over 1, 2, 3, 4. 1, 2, 3 over 1, 2, 3, 4. And then draw your line. And it's a little hard for me to draw this on with, okay, but I will, okay, I think that's the best I can do. So there's the original line. Now we want to make another line that's parallel through 3, 2. So it's going to go through 3, 2. Let's go ahead and plot that. 1, 2, 3, 1, 2. There's the point 3, 2. And it's parallel. That means it's going to have the same slope. So -3/4 is going to be the same slope. So we'll go down 1, 2, 3 over 1, 2, 3, and just missed it by a little bit. So we'll go up. Over 1, 2, 3, 4, up 1, 2, 3. Okay, so we use these two lines. Those are the best ones to use. And now you have graphed the line and a line parallel to it using the same slope for number 14. Okay. Okay, 18, 19, and 20. Draw a triangle MGT. Okay. Need some space to draw here. I can also pick triangle. Okay, triangle M, G, and T. Use a triangle to answer the questions below. What angle is included between GM here and MT here? The angle that's included where those two sides meet is angle M. And notice that's the letter they have in common, M and M. Okay, which sides include angle T? Let's start over. And this is for 18 through 20. So which sides include angle T? So here's angle T, and the two sides that include it would be side GT and side MT. Notice they both use the letter T. This side and this side. Where they meet, they include that angle T. Okay, and then what angle is included between segment GT and segment MG? So here's segment GT and segment MG. Which angle is included? That would be angle G. Where the two sides meet, angle G is included. Okay, 21 and 22. Name two triangles that are congruent by angle, side, angle. That means the side is going to be in between the two angles. Okay? So if we look, they have to all match up. So this triangle doesn't have any sides marked, so it can't be this triangle. Let's check and make sure these work. There's an angle, a side, and an angle with 2 marks. Okay, over here there's an angle, a side, and an angle with 2 marks. So using this angle, side, angle, I would say that these two triangles are congruent. Okay? I would call that, it says name two triangles. Well, we'll say triangle. I've covered up the letters now. Triangle IJH is congruent to triangle. What corresponds to I? L does. What corresponds to J? K does. And what corresponds to H? M does. So those two triangles are congruent. This one and this one. Okay, I didn't use this side over here because the triple angle mark and the double side mark did not match anything over here. 22, angle side angle. Once again, I have angle side angle, angle side angle, and angle side angle for all three of these. Now I have to see which ones match. This has a double arc. These do not. So these two triangles will be the ones that you can prove congruence, not this one. So we can say triangle RTS is congruent to triangle. R corresponds to Y, T corresponds to Z, and S corresponds to X, these two triangles. Okay, 23 through 26 says in each diagram the stated triangles are congruent. Separate and redraw the indicated triangles. Identify any common angles or sides. The triangle BAE, so here's BAE, looks kind of like this. Okay, and then triangle ABC, A to B to C. And that's the right angle. So the sides they have in common would be side AB is congruent to side AB. They share that side. That's the only completely common side or angle that they have. Segment AB. Okay, 24. Let's try the straight line tool. Okay, 24 says triangle SUV. S to U, U to V. That's much better. Okay, so S, U, and V, and then triangle WUT. So W starts here to U, U to T, T back to W. Okay, and they both share that angle U, both triangles. So U is congruent to U for 24. 25, AFC, or ACF. A to C, and then AEB. AEB. So this is ACF and AEB. And they both share that angle A. Angle A be the answer. 26. FKJ. F to J, J to K, like that. And then the other one, HJK. I'm running out of room. This is F, J, K, and this will be J, K, and H. And they both share that segment JK. Those triangles. Okay, numbers 27 through 30 I did on the other video, and I also did number 33 on the other video. So we'll look at 31 and 32 and 34. draw some places to work up here. Okay, 31. We're trying to find x and y for all of these. So this is 115. That's the only number I'm given. I know this is an isosceles triangle. So if this is 115, I can find this angle. 180 minus 115 gives me 65. So this is a linear pair. So this is 65. This is an isosceles triangle. These are the two congruent sides. This is the vertex angle. Therefore, these are the congruent base angles. So I now know this is 65. X is equal to 65. Okay, so now we have 65. This is 65. We want to find y. All three angles in a triangle add to give you 180. So I would say 65 plus 65 plus y is equal to 180. 65 plus 65 is 130. Subtract 130 from both sides. So y is equal to 50. X is 65. Y is equal to 50. Okay, for 32, I want to find x and y. And the only number I'm really given is this 90 here, this right angle. And it's an isosceles right triangle. That means these are the two base angles. The right angle is the vertex angle. That means that this is y. So I now know that y plus 90 is equal to 180. I'm only looking at this bottom right triangle. That's 2y plus 90 equals 180. If I subtract 90 on both sides, 2y is equal to 90. So y is equal to 45. Okay? Well, these happen to have the same markings, and they share this side in the middle. That means these are congruent triangles. Therefore, y is equal to x. So x would also be 45. Okay, and then number 34. You could do this without using an isosceles triangle. X and 110 are supplementary. That means that 180 minus 110 gives you 70. So x is equal to 70. And you could just look in this one triangle here. 90 plus 70 plus y is equal to 180. 90 plus 70 plus y is equal to 180. 90 plus 70 is 160. Subtract 160 on both sides. So y is equal to 20. Or you could say, okay, well, this is an isosceles triangle. You could say x is 70. That means this is 70. 70 plus 70 is 140. That means this whole angle would be 40. 70, 70, and 40 all equal 180. And you split that in half because it's a perpendicular bisector. So y would be half of that, which would be 20. Okay, number 35 is also on the other video, along with 36 and 37. Okay, 1 through 6 here with proving triangles congruent. I'll go through these rather quickly. We've practiced this a lot in class. You've got to make sure you can understand and look for the important parts in order to prove that they are congruent. Okay, number 1, I see that this is congruent to this, and that's congruent to this. These are vertical angles. If this is 90, this is 90. So I would say this is side-side angle because the angle is not in between the two sides. Okay? But that doesn't prove congruency. And I noticed these are right triangles. Okay? They have two right angles. That's the first thing. The hypotenuses are congruent. That's the second thing. And they have one pair of legs that are congruent. So are these triangles congruent, or can we prove them? Yes, by hypotenuse leg. Okay, number 2, this side is congruent to this side. Oops. And this side is congruent to this side. And they share this side in the middle. So all three sides are congruent, so yes, by side, side, side. Okay, over here, we have the vertical angles, and we have this angle marked, and we have a side marked. So I notice there's one side and there are two angles in each triangle. Well, is the side in between the two angles, or is it not? It is in between. Side, and these two angles are on either side of it. If you picked up that side, the two angles would be attached. So the answer would be angle, side, angle. Yes, they're congruent. That proves congruency. Here, I have an angle and an angle, an angle and an angle, and they share that little side in between. So this side is not in between these two angles of this triangle or these two angles. So this would be angle, angle, side. Does that prove congruency? Yes. Okay, number 5, I have this side congruent to this side, and this side congruent to this side. I have a side and a side, no other side, no other angle. So not enough information to be proving congruent. So we'll say can't be proven. You have to have at least 3 pieces of information. Okay, number 6, they share this side, and these two sides are congruent, with the angle stuck in between that's congruent. So this would be side, angle, side. Does that prove congruency? Yes. Okay, number 7, they share that side in the middle. They have this side marked and this side marked, and they have one angle congruent. The angle's not in between those two sides, so this would be side, side, angle. That doesn't prove congruency, but I do notice these are right triangles. They have right angles, the hypotenuse is shared, so it's congruent, and the two sides are congruent. So this is, or one pair of legs are congruent. So this would be hypotenuse leg, and this proves congruency. Yes. Once again, hypotenuse leg, this is a right angle, this is a right angle. They have the hypotenuses are congruent, and they share a leg. So this would be yes, hypotenuse leg. Okay. Number 9, angle matches this angle matches this angle. They share a side in between. The side's in between the two pairs of angles. So it'd be angle, side, angle. Does this prove congruency? Yes. Number 10, they share this side, angle, angle. This side's marked congruent to this side. This would be side, angle, side. Does that prove congruency? Yes. They share this side. This is side, side, angle. The angle's not in between the two sides. If it were there, it'd be side, angle, side. So this is side, side, angle. And this over here is side, angle, side. They have to match. Does that prove congruency? No. Need more information. Can't be proven congruent. Okay, number 12, this side matches this side matches this side, and they share a side in the middle. So these are proven congruent by side, side, side. 13, they have vertical angles they share. This side and this side are marked congruent to this side and this side. Over here it says side, angle, side. You have to check and make sure both triangles match. Over here this would be side, side, angle, because the angle's not in between the two sides. These don't match, and this doesn't prove congruency. So we say can't be proven congruent. Okay, over here they share this side. This angle's congruent to this angle. This angle's congruent to this angle. So is the side in between the two angles? Oops. No, it's not. Is the side in between these two angles? No. So it'd be angle, angle, side, not angle, side, angle. And yes, this proves congruency. Okay, 15 and 16 state what additional information is required in order to know that the triangles are congruent for the reason given. Side, side, side. I need 3 sides. I have one side, two sides, one side, two sides. So I need to know that this side is congruent to this side. So I could say segment CE is congruent to segment, I think it's a J and an H. CE is congruent to JH. That's the other information that I need. Angle, angle, side. Okay, I have this angle and this angle congruent. There's one angle. I have this side and this side that are congruent. And notice that the sides and the angles touch. That would be these two. I've already gotten those. I need one more angle that doesn't touch that side. I wouldn't choose this angle because it touches the side. I'm going to choose this angle, and I'm going to choose angle C. So angle Z should be congruent to angle C. 17, angle, angle, side. I have no angles marked, But I know that this is congruent to this because they're vertical angles. I have one side. The angle and the side are touching, so those are already taken care of. I need one more angle that doesn't touch the side. So that would be angle E and angle S. So angle E would be congruent to angle S. Hypotenuse leg. I have the two right angles already. I have one leg here, but I don't have the hypotenuse. Remember, the right angle points to the hypotenuse. So I need this to be congruent to this, which would be DC should be congruent to segment NM. The last few, let's see, 19, angle, side, angle. I have one angle, I have a side they share, I need the other angle on the other side of the side. I need this angle to be congruent to this angle. So you have to be specific because more than one angle is using the letter F. So I would say angle RFQ is congruent to angle AFQ for 19. For 20, hypotenuse leg, I see one of the legs is marked, so I need the hypotenuse. That would be this needs to be congruent to this. So UT should be congruent to, I think that's segment AB. Okay, 21, got a little cut off in the picture, but this side here, JD, is marked congruent, and HI is congruent, and they share this side in the middle. I need to be side, angle, side. Well, I have the two sides taken care of. I need this included angle between the two sides. That would be this angle and this angle. I would say angle HI needs to be in the middle because it's a vertex. HIJ is congruent to angle, that's a D, we can't see. DJ has to be in the middle because it's a vertex, I. And the last one, 22, side, side, side. They share this side, they have this side marked. I need the other side to be proven congruent. Segment FG is congruent to segment RE. I hope this helps. Good luck with studying. Make sure you study your notes, your classwork, your homework, anything that we've covered in class. And if you missed something on the study guide, make sure you watch parts of this video or you look up the information that you missed.